Composition of functions. Do not get too confused with this. Composition of functions is essentially substitution. You're going to see it written two different ways. And you're going to see it like f g of x, and you're also going to see it like that. They mean the same thing. This says f of g of x, and this says f of g of x. Basically what it means is you're going to take the g of x function and plug it into f. So if f were something like x plus 2 and g of x was maybe 3x minus 3, okay? The way that this would look, if they're asking us to find f of g of x, that means replace g of x with the function g of x. So this will look like f of 3x minus 3, okay? Now, what that means is take the 3x minus 3 and plug it in for x in the f function. So I'm going to take this and replace it with x. So that's going to be, put it in parentheses, 3x minus 3, and then plus 2. Now we just simplify that. So getting rid of the parentheses and now combining like terms, that would be our solution. Okay, so do not get too confused with this. It just simply means plug the other thing in for that. So let me give you another example. Let's say they're asking for g of f of x. All right, so you work from the right to the left. Let's say g of x equals x squared minus 2. F of x is 3x. Okay, so you work from left to right. It says plug f into g. So I'm going to plug this into that. So they're asking for g of 3x because this is the same thing as that. Okay, g of f of x, g of f of x. Now, take f of x, plug it into g. So everywhere I see an x, I'm going to replace it with 3x. So I have 3x squared minus 2. That makes 3 squared is 9, and then x squared minus 2. That's our solution. Let's say that they do something like g of f of 3. Okay? Now, here's what that means. This means g of f of 3. They're both the same exact thing. Now, this means take 3, plug it into f. So the way I'm going to look at this first is f of 3. Well, that means replace this x with a 3. So that's 3 times 3, which equals 9. So f of 3 equals 9. Now I have to plug this in for that. So that gives me g of 9. Now plug 9 in for g function. So that means 9 squared minus 2. Well, that's 81 minus 2, which equals 79. Let's look at another one. Let's keep the same function. So g of x equals x squared minus 2. F of x still equals 3x. Okay? Let's say that they do f of g of negative 1. Okay? Work from inside out. Inside out. So I have to do the g of negative 1 part first. So g of negative 1. That means plug negative 1 into the g function. So that is negative 1 squared minus 2. Well, negative 1 squared is 1 minus 2, which equals negative 1. Now, I know what g of negative 1 is, so I'm going to replace g of negative 1 with this. So that means f of negative 1. Okay? Plug this in for the x. 3 times negative 1, which equals negative 3, and that is your solution. You are simply substituting things in. Okay? Let's look at a different type of problem. Let's give you 3 terms maybe this time. So g of x equals 2x plus 5. F of x equals negative 2x. And let's let h of x equal x squared plus 7. All right? So you have 3 different functions this time. All right, now they might get a little bit confusing and say, hey, let's find f of g of h of negative 2. Something like that. Now, that looks big and scary, but work from the inside out. So h of negative 2. That means plug negative 2 in for x in the h function. So let's find h of negative 2. Well, that means plug negative 2 in there, so that's negative 2 squared plus 7. Well, negative 2 squared is 4 plus 7, which equals 11. Now plug that into the g function, so that means g of 11. Well, that's 2 times 11 plus 5, which equals 27. Now it means I got to plug this into f. So f of 27, and that's going to be negative 2 times 27, which will give me a final answer of negative 54.